Hi everyone, Professor Christina Sover here from Cal State Long Beach speaking, and in this video we're going to go back to some pattern problems and talk about what to look for and make sure of and make reasoning with when we're looking at different patterns. I chose this one, which is almost identical to a previous video, because there's a slight twist going on in this question, and I wanted to help utilize that twist to our benefit to see how we might use our intuition even more. What is the perimeter of the nth shape of the pattern below? The big idea here is perimeter, distance on the outside. I've had several students work on questions similar to this one and include these dashed toothpicks on the inside in their function. And we're very disappointed to find out that those toothpicks are not included. When we're talking about the perimeter, we're just walking on the outside of the figure. So just these ones out here, almost like a track. So one other thing is perimeter. These shapes to me, that little track I drew, look like a rectangle. I know the perimeter of a rectangle. I've seen that formula before. That's equal to 2L plus 2W. You add up all the sides. 2L is the length and 2W is the width. Well, if I draw a picture of a rectangle, I might say that L is the vertical length and W is the horizontal width. Let me shrink that picture slightly, and using knowledge I already had, I'm going to find the model or the pattern for this array of pictures. I'm going to have the number of toothpicks for side length L, and I'm going to have the number of toothpicks for side width W. And then I'll have the shape number. Shape number before was the number of squares, but they're calling it shape number now. We had shape 1, shape 2, shape 3, shape 4. Why don't we do shape 5 and see if we can't jump to N after the fact? Okay. Give my computer a second to catch up. Sorry about that. I'm going to have my length L toothpicks be green, and I'm going to have my width toothpicks be orange. So I'm just going to go through and highlight one width and one length for each image. So we'll start with width. Here's the width. Everybody's got the width. I'm going to highlight my diagram as you before too to see what's going on there. And then we're going to do our length. Match up how I highlighted it before. All right, that's consistently highlighted. For shape 1, my length is 1. For shape 2, my length in green is 1. Same for 3, same for 4. I'm going to bet same for 5. And then for N, it's also going to be a 1. Cool. Now for the number of toothpicks for the width W in shape 1, I highlighted 2 toothpicks. In shape, just 1 toothpick. I lied to you. 1 toothpick in shape 1, 2 toothpicks in shape 2, 3 toothpicks in shape 3, 4 toothpicks in shape 4. Well, those numbers match with the shape number, So I'm going to say 5 toothpicks in shape 5, and then N toothpicks in shape N. Well, then the formula for the perimeter, let's scooch this up a little bit. The perimeter is just 2L plus 2W. I'm going to color coordinate it again. L is green, W is orange. So the perimeter should be 2 times 1 plus 2 times 1, which is equal to 4 for shape 1. That's good. 2 times 1 plus 2 times 2. That's equal to 6 for shape 2. That looks good. 3 times, oh, why did I put 3? Oh no, see, when you start thinking that the shape number goes with the 2 and the L, you gotta make sure what's going on. It's 2 times the length, which is 1, plus 2 times the width, which is 3, which is equal to 8, which is solid. Now it's 2 times the length, which is 1, plus 2 times the width, which is 4, and that's 10. 2 times the length, which is 1, 2 times the width, which is 5, which is 12. These numbers look consistent to what we got with the inside versus outside only for the toothpicks. So that 12 was for the outside number, toothpicks for 5. That looks good. And so for N, it's 2 times the length, which is 1, plus 2 times the width, which is N. So for the perimeter shape N, we're going to get 2 plus 2N. Or you can keep it as 2 times 1 plus 2 times N, either one. And our functional rule is indeed trustworthy because we trust the perimeter of the area of a rectangle, and these toothpicks look very much like rectangles to me. I just want to bring up this example of looking at the picture in a slightly different way because looking at the same image but in a different lens could confuse some folks. And I wanted to see how you could still use your intuition to solve out this question. If there's anything else I can help clarify, or you have any other examples you want to do together, shoot me a message. I'm happy to help you as soon as possible. Thank you so much for watching. Stay safe. Talk to you soon. Bye.